So 5.4 is talking about isosceles and equilateral triangles. Remember, for an isosceles triangle, there's at least two sides congruent, but there's different parts that have names of an isosceles triangle. If you just have two sides that are congruent, as shown by my diagram here, the two congruent sides are called the legs. The side that's not congruent to the two other sides is the base. The point where the two legs meet is the vertex, which means where the two legs intersect, the angle formed there is the vertex angle. And then these two angles that are made up of the base are the base angles. So those are all the different parts of an isosceles triangle. So then for theorem 5.6, which is the base angles theorem, states this: if you have two sides of a triangle congruent, in other words, it's an isosceles triangle, then the angles opposite those two sides are congruent. So if I label this triangle ABC, side AB is congruent with side BC. The angle opposite side BC is angle C, and this angle opposite side BC is angle A. So those two angles would be congruent. And then there's the theorem written out. You could also say if a triangle is isosceles, then the base angles are congruent. That's why it's called the base angles theorem. And then since I wrote the base angles theorem in terms of a conditional statement, the converse of that is true. So if you have two angles in a triangle that are congruent, let's just say this is my triangle, I have these two angles congruent, then the sides opposite those two angles are congruent. The side opposite this angle is this side. The side opposite this angle is this side. So then the two sides would be congruent in that triangle.